I'm coming back in my live session. So today I talk about TDS and pH in the water fact. So first of all, I talk about what are TDS. TDS stands for total dissolved solid and represent the total concentration of dissolve, right? To substances in water. TDS is made up TDS is made up of inorganic salts as well as a small amount of organic matter. Common inorganic salts that can be found in water include calcium, magnesium, potassium, and sodium, which are cautions and carbonates, nitrates, biocarbonates, chloride, and sulfurs. So, why are all anions? Cautions are positively charged ion and mm, anions are negatively charged ion. How do this solid end up dissolved in water? These minerals can mm, originate from a number of sources, both natural and as a result of human activities. Mineral springs contain water with high level of dissolved solid because the water has flow through a region through the rock have a high salt content. The water in the drier provinces trend to have high level of dissolved solid because of high amount of calcium and magnesium in the ground. These minerals can also come from human activities, agriculture, and urban runoff and carry excess minerals into water sources, as can wastewater discharge, industrial waste water, and salt that is used to de-ice roads. So, what happened to the water when the TDS level is high? Alone, a high concentration of dissolved solid it is usually not a health hazard. In fact, many many people bathe mineral water, which has naturally elevated level of dissolved solid. The United States Environmental Protection and Agency, which is responsible for drinking water regulation in the United States, including TDS as a secondary standards, meaning that it is a voluntary guideline in the United States. So United States, while the United States set legal standards for many harmful substances, TDS along with other contaminants that cause aesthetic, cosmetic, and technical effects has only a guideline. So most people think of TDS as being an aesthetic factors. So in a study by the World Wealth Organization (WHO), so a panel of tester come to the following conclusion about the following performable level of TDS. TDS level of is a milligrams per liter, less than 300. So it is a excellent for a drinking. And 300 to 600 what the drinking water, and 900 to 1200 is a very poor of drink water. Above 1200 is a unacceptable for your body. So however, a very low concentration of TDS has been found to give water a flat taste, was a undesirable to many people. So increased concentration of dissolved solid can also have technical effects. Dissolved solid can produce hard water, which leaves deposits and forms on fixtures and on the inside of hot water. 5 and boilers, soap and detergents do not produce as much leather with hard water as soap with soft water. As well, high amounts of dissolved solid can stain household fixture, corrode pipes, and have a metabolic taste. Hard water cause water filter to wear out sooner because of the amount of minerals in the water. The picture below has taken near the Mammoth Hot Springs in Yellowstone National Park and show the effect that the water with high concentration of minerals can have on the landscape. So the same minerals this despite of on this rock can cause problems when they build up the pipes of treasure. So deposition from minerals in water at Mammoth Hot Springs. So however, while TDS itself may be only an um, aesthetic and technical factors. A high concentration of TDS is an indicator that harmful contaminants such as iron, manganese, sulfate, bromide, and arsenic can also be present in the water. So this is especially true when the excessive dissolved solid are added to the water and human pollution through runoff and wastewater discharge. So I talk about now what are the guidelines for TDS. In Canada, substance that are considered to be dangerous is high amount of list as listed at maximum acceptable concentration. In the Canadian guideline for drinking water quality, however, substances that are not considered dangerous at their MSC. MSC means maximum acceptable concentration. So such as TGS are given an aesthetic objective in the guideline. The Canadian guideline for TDS is less than 500 milligram per liter, while it is the same as 500 parts per million. So however, since the Canadian guidelines are not enforceable, um, province is free to choose whether or not they will follow the guideline. um, Shak Chetan has water has naturally contain high concentration of TDS, so the previous thus chosen to not follow the Canadian guideline to the 500 part per million and to implement its own guideline in 1500 parts per million. So in the United States, substance that the health based have maximum contaminants level and the unforceable by law. So, however, TDS and other substances that are considered aesthetics are given secondary maximum contaminants level, but not enforced because they do not pose as great a health risk as a primary contaminants do. The United States guideline for TDS is also 500 parts per million. So how can water treatment facilities remove TDS? How can water treatment facilities remove TDS? Water treatment facilities can be reverse osmosis. Reverse osmosis means O RO water. RO water to remove the dissolved solid in the water that are responsible for elevated TDS level. So reserve osmosis removes virtually all dissolved substances, including many harmful minerals such as salt and lead. It also removes highly minerals such as calcium and magnesium. And ideally, such water should be filtered through a magnesium and calcium magnesium bed to add and the minerals to the water. The mineral bed also the pH and decrease the corrosive potential of the water. For the more information about rivers osmosis salts, uh, and now I talk about what is pH. The pH value of water source is a measure of its acidity or alkalinity. The pH level is a measurement of the activity of hydrogen atom. pH means potential of hydrogen, and talk about this power of hydrogen. So, so pH level is the measurement of the acidity activity of the hydrogen atoms, because the hydrogen hydrogen activity is a good representation of the acidity and alkalinity. The pH scale as shown below range from 0 to 14, with 7.0 being at neutral. Water with a low pH is said to be a acidic, and water with a high pH basic or alkaline. Pure water pure water should have a pH of 7.0, but water source or prescriptions tends to be slightly acidic due to contaminants that are in a water. So the pH scale is logarithm wise, means that each step to the pH scale represented a tenfold charge in acidity. For example, a water body with a pH of 5 is 10 times more acidic than water with a pH of 6, and water with pH of 4 is 100 times more acidic than water with the 6. So how does the pH of a water source changes? Surface water typically has a pH value between 0.6.5 to and 8.5, and underground tend to have a pH between 6 and 8.5. The pH of a water source can vary naturally. Some types of rock and soil such as limestone can neutralize acid more effectively than other types of rock and solids such as mm, granite. Or when there are a large number of plants growing in a lake or river, they released carbon dioxide. Then when they die and decompose, when the carbon dioxide mixed with the water, a weak carbonic acid is formed. This can then cause the pH of the water body to decrease. So a number of human activities have a harmful effect on the pH of nearby water sources. When sulfur dioxide and nitrogen dioxide are emitted through through industrial operation and vehicle, and acid rain can be produced. For more information about acid rain, see there. So chemical pollution from industrial operation, individual of communities can cause a water body to become acidic. So these chemicals can enter the water through illegal discharges of, or after inadequate water waster treatment. So question is that what happen when the pH of water changes? The changes in the pH of water can have a number of consequences in the environment. So many plants and animals are harmed or even killed. As a result of acidification, many varieties of fish and aquatic life are extremely sensitive to change in water temperature and composition. The below diagram illustration the pH that is required for a number of adequate species. Notice that when the pH is around 6 to 7, which is natural for many lakes and streams. The biodiversity when the ecosystem is wide. As the pH decreases and the acidity increases, as the pH decrease and acidity is increase, fewer and fewer organism can survive. So acidic water is synthetic, which means that a combination of low pH and the increased concentration of um, concentration of certain substance for is far more harmful than the sum of the parts. So, for example, aluminium, lead the mercury are potentially dangerous substances. So, but when the pH of the water source is already low, this substance can be extremely detrimental, a consequence for adequate life. So acidic water can also cause problem for human consumption, while slightly acidic water is not dangerous on its own. It can be quite dangerous when combined with other compounds. So water with a pH that is less than 6.5 can leach mental ion. Sorry, sorry. This is called is metal ions including iron, manganese, copper, lead, and zinc from plumbing fixtures and pipes. This is return can be quite dangerous. On the other hand, other end of the pH scale, water that has a pH greater than 8.0 can be difficult to drinks. The World Health Organization recommends that the pH of the water be less than 8 because basic water does not allow the effects chlorination. So, what are the guidelines for pH? Like pH is given the aesthetic objective in Canada. The Canada guideline for the drinking water quality suggests that the pH of drinking water should be between 7 and 10.5. The drinking water standards and objective recommend that the pH of drinking water be between 6.5 and 9. In the United States, USA, like TDS is secondary standards, the secondary maximum contaminant level of pH is between 6.5 and 8.5 according to the EPA. And noticeable effect of a pH that is a less than 6.5 include a bitter, metallic, metallic taste and corrosion. The noticeable effect of a pH above 8.5 including a slippery feeling, soda-like taste and despite. So how do water treatment facilities change the pH of water? There are several methods that can increase a pH of water before disinfection. So the pH is commonly increased using sodium carbonate and sodium dioxide, but a better way to dealing with low pH in the use calcium and magnesium carbonate, which not only will increase pH level, but will also make the water less corrosive. And both calcium and magnesium are the health benefits of opposed to sodium. So why it is important to monitor TDS and pH? It is important to monitor the TDS level and the pH of drinking water of several reasons. When a water has a high level of TDS or a low pH, is a likely that there are another harmful contaminants in the water. So both TDS and pH are also easy to measure, and pH something is happening to a water, such as pollution and changes are both TDS and pH level will change. So keeping track of those change can act as an early warning signal that something is happening to the water. For this reason, it is important to monitoring the TDS and pH levels so that if they change, action can be taken immediately. So for the Safe Drinking Water Foundation has educational program that can supplement the information found in the fact sheet. So Operation Water Drop look at the chemical contaminants that are found up in water. It is the design of science class. Operation Water Flow look at water use, etc., etc. So this is my end of my live session. So how is this? You can comment, and you are also subscribe this channel, and I will come back tomorrow in live session. So till then, God bless you. Thank you. Goodbye.